Hello and welcome to Dr. Kate's tutorial on creating a calibration curve. We're going to work through an example that is based on the iron experiment from Analytical 1, but it is applicable to any calibration curve you might need to create. I've got a blank sheet here on my spreadsheet, and you can see the different sheets down at the bottom here, and each one can be a completely different set of data or a different analysis that you want to do. On sheet 2 here, I have a set of data from an iron experiment. And so this is typical of the output that you would get from the iron experiment. And I do want to point out that what I'm about to go through is really specific to the iron experiment, but the details we'll get into with calibration curves can apply to a lot of different experiments. The iron experiment is done using a plate reader, and this is the output. So we have all the different wells in the plates and all their absorbance readings. As you can see, if you look at the last 5 columns here of numbers, they're all around 50. Those are in fact empty cells. They didn't contain anything, so we can ignore them. What we do have here is we have our blank here in the first column, and then the first 4 rows are our standards and the bottom 4 rows are our unknowns. I'm just going to focus on the standards for the purpose of this demonstration because we're working on a calibration curve. So the first thing I need to do specifically for the iron experiment is get this in a format that I can copy into the spreadsheet template that you are provided with on CourseLink. So I'm going to do some copying and pasting here. So I'm going to highlight just the standards. And one of the issues that we have is that our replicates are in columns here, but on the spreadsheet template, they're across in rows. So we need to rearrange these, and in Excel that's called transposing. So what I want to do is a copy and a special paste. So I'm just going to copy this, so click on copy, and I'm going to move to an empty space on my spreadsheet, and then I'm going to go to paste here, but I want a special paste. And you can see there's all different kinds of pasting that you can do, and the one I want right now is this one where you can see it's flipping from vertical to horizontal, and I want to do a transpose. So that's what I've done. I've got my transpose, so now I have my replicates going across instead of down. The other problem we have with this data is that you can see we have values that are in the tens and in the hundreds, but absorbance values are typically less than 1. These aren't the actual absorbance values. They all need to be divided by 1,000. The absorbance on this sample was not 208, it's 0.208. But the output from the plate reader doesn't put the decimal place in. So I want to divide everything by 1,000. So all functions, when we enter them in Excel, start with an equal sign. And you can see up here we have the function box. So it shows us what we're doing. So equals, and then I click on this cell, and then divide, so a slash, and then by 1,000. So I've taken that number and divided it by 1,000, got 0.044. Now if I move the cursor into the bottom right corner of the cell, you can see I get the little plus sign, and that will allow me to copy. So if I pull that across, it fills in. All right, and then if I pull it down, so I now have all of these numbers here have all been divided by 1,000. That's the data that I want to work with. Top row is my blanks. The rest of the rows are my standards. So I'm going to copy this over to a blank spreadsheet so that I can then work with it and not be overlapping with any of the other things I have here. So I'm just going to do another copy, and then I'm going to move to sheet 3. Now, if I paste it just as is, you can see we end up with all of these errors. And the reason being that it has copied over the formula where we divide it by 1,000, but of course there's no cells there for it to divide by 1,000. So it's giving a reference to a cell that doesn't exist. So that's not the kind of paste I want to do. So I'm going to undo that, and I'm going to go back. I'm going to go back to my special pastes, and what I want are to paste the values. So it's just going to actually put the numbers that the formula created. So there's my paste values. Again, blank at the top and the standards below. So I'm going to separate the standards from the blank. So there's my standards, and I'm going to start to label things. So I've got my absorbance readings. That's what those ones are. And this is my blank. And over here, I need to calculate an average of the blank because I need that in order to calculate my corrected absorbances. So I'm going to calculate an average. And Excel's really good at doing math, so you don't have to be quite so good at doing math when you're using a spreadsheet. If you want to calculate an average, we type in a function called the average function, and it's really easy to remember because it's the word average. So average, And then for what we want to average, we have to put it inside brackets. So we open a bracket, and then we highlight the things we want averaged. You can then either close the bracket and hit enter, or you can just hit the tab key and it finishes it off for you. So there we go. We have the average blank. Now this has too many sig figs on it. So already we're starting to get into formatting issues. So these little buttons up here at the top, they control how many decimal places are being shown. So I can decrease the number of decimal places on this so that it's showing the correct number of sig figs, which would be the same numbers we have for all of our blanks. Down here we want to calculate a corrected absorbance. So I'm going to put that in. Corrected absorbance. And our corrected absorbance is our value, our absorbance reading that we have, and we subtract the average blank. Okay, so I went from 208 to 165. So I can copy that across. Okay, but how come that one's 165, but then these are quite a bit higher? Well, they haven't changed. 215, 215, 222, 222. They haven't changed. But if I look at the function here, I'm still subtracting something, so why hasn't the number changed? Well, you can see that when we copied the formula over, that both of our numbers that we were subtracting have moved over one cell. So for this cell, when we subtract, we do B7 minus F3. When we copy it over to this cell, we move over one, so C7 minus G3. But we don't want this one, the blank, to move. Okay, so how do we get around that? Well, Excel is capable of doing all kinds of neat stuff, and one of the things that you do is you can put in some notation that says, I don't want this cell reference to change when I copy this formula to another cell. And the way you do that is you put dollar signs in. The dollar sign is on the 4 button on your keyboard. Directly above that is the F4 key, the function 4 key. So if you hit the F4 key, you can see it puts in the dollar signs. Here, I'll move the mouse. So you puts in the dollar signs in front of the F and the 3. Now, there may be situations where you only want one or the other to change. Maybe just the F, maybe just the 3. So if you keep heading F4, it cycles through all the possibilities. So no dollar signs, $2 signs, just on the number, just on the letter, back to no dollar signs. So I'm going to put in both of them because I don't want either the number or the letter to change in my cell reference. Now if I copy that across, you can see on this one, it has stayed with F3. Now we want to copy that down. We have all of our corrected absorbances. Finally, we want an average corrected absorbance. So again, I'm going to label it, put in the average. And so we want the average of these 4 numbers. And we could type the formula in again, or actually I know that this formula is actually the average of the 4 numbers next to it. So I can just copy that, put it here. And there we go. We have the average of all of our corrected absorbances. Now I'm going to plot this versus aliquot size. So my aliquots were 30, 50, 70, 90, 110, and 130. If you were plotting a calibration curve, this would be concentration. All right, so it would be some kind of concentration units. So you have to calculate the concentration of all of your standards so that you can do the graph. So these values here are going to be our x's, and these values here are going to be our y's. So now we have to create a graph. Now in Excel, the software assumes that your first column is your x's. All of the subsequent columns are your y's. So these would be y1, y2, y3, y4, etc. So our graph is going to actually have a whole bunch of extra stuff in it that we don't need. So to avoid that, what we can do it a couple different ways. So maybe I'll show you both ways. So the first thing we can do is we can just highlight that whole thing, go to Insert, and make sure you pick a scatter plot. Do not pick a line plot. A line chart is used, it says right there, used to display trends over time. So you would use this if you were doing temperature over days of the week or months of the year, or rainfall or something along those lines. It makes all of your X points evenly spaced regardless of their value. The X numbers are just treated as labels. They are not actually treated as numbers. So what you want is a scatter plot, because this treats both X and Y as actual numbers. Now you have a lot of options. You can plot just the points. You can plot the points with a smooth line. You can plot the points where you and just join the points together with a straight line. You can have a smooth line without any points, and you can have just the straight line without any points. We want just the points. So there's our graph. All right, immediately we have a problem, and you can see from here, because of the shape of our table, Excel is assuming that the top row is our x's and everything below it is y's. That is not correct. We have our x's in our first column, and everything to the right of it is y's. So we need to switch row and column. So that's that button there. That looks a lot better. We now actually have everything we need. We actually have a lot more than we need. So as you can see, there's 9 different series here. We actually only want the last one. So we can go into select data and just delete all of the other series except for the last one. Remove. There we go. Okay. So here's our graph. We only have one set of data, so we don't need a legend, and I personally can't stand the lines, so I take those out too. Now I can see all of my points. Now our graph doesn't have any titles on it, so if we go to here under layout, we can do a chart title, and we can also do axes title for both axes. We would label the y-axis as absorption, and usually you want to include the wavelength either in the axis title or in the chart title. The x-axis would be concentration. Don't forget to include units on that. We've got our graph, and that's one way that we could do it, by getting all of the points and then deleting the ones we don't want. The other way to do it would be to insert a graph that's empty. So you can see this one's empty. Doesn't have anything in it because we didn't highlight any data before we started. And then we can go to select data. We can add a series, and then we can pick our x's. So this is our x's, and then we can pick our y's, and we're done. We have exactly the same graph. We can get rid of that. We can get rid of that. Still have to put the titles. Before we go on to doing the linear regression, I do want to show you a couple of things for double checking. And again, this is specific to the iron experiment because we have many replicates on our standards. It's always a good idea to check for outliers. So I'm actually going to create another graph. This is not a graph that you would hand in or use for anything. You're just checking the quality of your data. So I've just highlighted my X numbers and then my individual replicates on my absorption, and I'm going to put in a scatter plot, and this is what it looks like. So here we have another graph, and again, I don't need the lines. They're just distracting. But if we look at this, you can see we have some outliers. There's a big outlier right there. That one could definitely be removed. You could do a Q-test. You've got 3 points that are all overlapping up here. That one you should be able to remove, no problem on a Q-test. This one may be on a Q-test, and this one may be on a Q-test. So I would go through the stats for these and see which points I could remove. If we've decided to remove a point, so if we're removing the 512, which is right here, what I do recommend is you never want to delete raw data because you never know if you might need it again at some later point. But there's no problem with removing the corrected absorption. So if we remove it there, it's gone from our data. For our graph, I've removed an outlier fairly easily. We could remove the other outliers as well if we wanted to. But going back to our plot, but now I want to do a linear regression. So pretty easy to do this on the graph. Right click on any one of the data points, go to add trend line. The default on this is for a linear trend line. You can see that right here. If we go down to the bottom, we want to display the equation on the chart, and we want to display the r-squared value on the chart. So the equation is the equation of the straight line that fits our data. The r-squared value is the correlation coefficient, which gives us an idea of how good the linear fit is. The closer r-squared is to 1, the better the fit. So if we close that, here's our little table that's got all of our data from it, our linear regression. And now we have the best fit line for our graph. If this comes up and you cannot see enough sig figs, so for example here, your slope only has 2 sig figs, which probably isn't enough since all of our data has 3 sig figs, you can reformat that little box and reformat the numbers within it. It's fairly easy to do, as with everything else on Excel. Just right click on it. So if I right click on here and go to Format Trendline Label, I can now pick what style of number I'm doing. So it's set, the default is for general. I can do it as scientific notation, and then I can increase the number of decimal places. If I have 2 decimal places, it'll automatically give me 3 sig figs. I could increase that to 3 decimal places if I wanted 4 sig figs, or I could do it as a number, and then I could increase the number of decimal places showing. So it was showing 4. If I took it up to 5, I now have 3 sig figs on my slope. Okay, the last thing that I want to do is to do the lie nest function, because this linear regression, it gives us the slope and it gives us the intercept and it gives us the R-squared value, but it does not give us the rest of the stats, which is the standard deviation in the slope and the standard deviation in the intercept, which we need if we're going to do error analysis. To get those numbers, we need to do a lie nest function. We need to highlight an area, and it can be anywhere on your spreadsheet. It needs to be 2 columns wide and 3 rows long. All right, so we highlight that, and then we go up to our function box, and we start to type in our function. So all functions start with an equals button, and then the function is called lie nest. So we type in LINEST, and we open a bracket. Now you can see it comes up with this little helpful box here that tells you what needs to be in the function for the function to work. So we need our known y's. Well, so our y values are our average corrected absorption. So we highlight those, and then we need a comma. The next thing we need is our known x's. So we go to our x's, and we need a comma. Now the next 2 are constants. So, and it shows you here what are the 2 possibilities. It can be false, which means b is set equal to 0, or true, which means b is calculated normally. What that is asking you is, do you want to force the line to go through the origin? Do you want the y-intercept to be 0? And in this case, no, we don't want to force it to go through the origin, so we're going to say true and comma. And then the next one is, again, true, false. True, return additional regression statistics, or false, do not return additional regression statistics. We do want the additional regression statistics, so again, we type true, and then we close our bracket. For this function, because it is creating an array of data, you cannot just hit enter. You have to hit Control-Shift-Enter. So Control-Shift-Enter. And as you can see down here, we've got 6 values. Now, the first thing that I want to do when I've done this is I want to make sure that it matches with my graph. I want to make sure that the data used for the lie nest function is the same as the data used on the graph, which means the slope, this is the slope, has to match 0.00641. That matches. The intercept also matches. So this is your slope in this box, and this is your intercept. Below each of those numbers is their standard deviation. So this is the standard deviation in the intercept, so SB, and this is the standard deviation, in the slope. This is the R-squared value in here, the 0.988, which matches with our graph again, so that's R-squared. And then this one is the standard error in Y, so SY. So our 6 numbers, we need the top 4 in order to be able to do any further calculations and to do error analysis. So that's everything you need to know to create a calibration curve. Thank you.